Alright, Year 12s, this is the last video on exercise 9a. So we're still looking at the definition of a derivative function. And what you can see there is a graph that you've seen before now. So this is getting familiar to you. I've got some function f of x, and I've got a point P, which has an x value of x, and therefore a y value of f of x. And then some point Q, which is h to the right of f. So if I look at that distance, to the right of P, if I look at that horizontal distance between P and Q, it's h. And if I look at the vertical distance between P and Q, then that is going to be found by subtracting the y values, f of x plus h minus f of x. So once again, I'm going to find this line, the secant PQ, that's meant to be a straight line. I'm looking for the secant PQ, and the gradient of the secant PQ is going to be y2 minus y1 over x2 minus x1, which gives me f of x plus h minus f of x over h, because that's my run. Okay, and that is basically the gradient of the line between two distinct points P and Q. Now, this becomes the derivative function when what I've got, we don't need this yet, when what I've got is h approaching 0. Now what we have is the gradient of the point at P. So this is its definition. This part here is the gradient of the secant, and this part is saying, well, but the distance between those 2 points is effectively 0. So h approaches 0. This is the notation, f dash of x. You'll see this notation, and this is the definition. Now, we can use this formula to find the derivatives of many functions, but there are other ways also. We have different formulas that'll help us. I know that you used this last year and that you met this last year. You definitely need to know this form of finding the derivative. And please remember always to put in your limit. At times in the past, one of the mistakes I've seen is people leave off this part, and that's incorrect. The derivative is not equal to the gradient of the line between 2 points. The derivative gives you the gradient at one specific point. Okay, the next thing we can do with this, and I'm not going to show you anything about that now, but we call it the tangent line. The tangent line is the line, let's say, at this point. So the tangent line at this point, which has an x value of a and a y value of f of a, it goes through that point and it has the gradient f dash of a. In other words, it is a straight line which goes through this point but has the gradient of the function at this point. Now, a curve like, let's say, a quadratic changes its gradient all the time. If I draw a quick quadratic here, you can see, and I'm going to use just my pen, that's a very lopsided quadratic. Here's the gradient, right? On my turning point, it has a horizontal gradient. Somewhere out here, the gradient looks like this. The further to the right I go, the steeper the gradient gets. So this curve has a changing gradient. So if I find this point here, which is the point A, f of a, if I find the gradient at that point, it's going to look like that. And if I draw a line through that point with that gradient, it's called the tangent line. Okay, that's the name of it. All right, now here's the last thing that we're going to learn in this little section, and that is how to find the derivative of a function by first principles. When you see by first principles, it means don't use any rules that you've learnt. You must use this. I think I'm going to run out of space on this page, but I've got spare paper here. All right. I'm going to start underneath, but I'll go on to the next page if I need to, because I know this ends up looking kind of long. So what I need to do here is I need to use this formula f of x, and I put it into this. Then I need to expand and simplify everything and see what I get. So to find the derivative from first principles, first of all, I'm going to write down f dash of x equals, because f dash of x means the derivative, and that's what I'm finding. And I'm going to write down the limit as h approaches 0. because that's what I've got in my formula. And then I've got f of x plus h minus f of x over h. For my next line, I will actually substitute the values from the equation from f of x into this. So limit as h approaches 0. Now f of x plus h, I need to substitute x plus h into this whole equation. So, sorry, no f there. I've got 2 times x plus h cubed minus 3 times x plus h. So squared. So I take this equation and everywhere I find an x, I replace it with x plus h because I'm doing a substitution. Now I need to subtract f of x. So I just subtract this whole thing and I do some nice big brackets to remind me that I need to subtract the whole thing. That's 3x squared over h. Okay, expand. As you can see, this is going to get long. Limit. Don't forget to write this at every line. The limit as h approaches 0. This expands to x cubed. Well, let's do it. 2 times x cubed plus 3x squared h plus 3xh squared plus h cubed. If you don't know your cubic expansion, you should learn it. It's extremely useful. I'm only up to here. I'm going to run out of space on this line. Minus 3 times x squared plus 2xh plus h squared. And then I subtract this, and this is going to be an addition. So minus 2x cubed plus 3x squared all over h. Don't forget your over h either. Equals limit as h approaches 0. I need to multiply this whole thing by 2. That's fun. 2 times x cubed plus 6 times x squared h plus 6 times xh squared plus 2 times h cubed minus 3 times all of this. 3x squared minus 6xh minus 3h squared. It's pretty straightforward. It's amazingly easy to make mistakes when you're doing by hand first principles. Take your time and be careful. Minus 2x cubed plus 3x squared. It's perfectly okay if you run out of space to just put that below in that way. It's a little bit dodgy, but it's perfectly understandable to anyone reading it. Equals. Okay, now I can start simplifying things. I've got 2x cubed here and minus 2x cubed here. They will cancel. I've got a minus 3x squared here and a plus 3x squared here. They will cancel. So what I'm left with is 6x squared h plus 6xh squared plus 2. Oh, and I've forgotten my limit. Limit as h approaches 0. What am I up to? Plus 2h cubed minus 6xh minus 3h squared all over h. On to the next page. How lovely and long this is. Still keeping my limit as h approaches 0. Now I can take out my common factor of h. This is not a coincidence. This always happens. We started with a polynomial. And if you start with any polynomial and you go by first principles, you will end up with a common factor of h at the end and your denominator will cancel. This always happens. Take out my h. I've got 6x squared plus 6xh plus 2h squared minus 6x minus 3h all over h. And the h is cancelled. Okay, so I've now got the limit as h approaches 0 of this expression in the brackets. 6x squared plus 6xh plus 2h squared minus 6x minus 3h. So what happens now is I effectively substitute h into this equation. So this term becomes 0, this term becomes 0, and this term becomes 0. So what I'm left with, now I lose my limit sign because I'm saying, all right, what will happen to this expression as h approaches 0? I'm left with this and this. 6x squared minus 6x. Now let's go back. I don't know how much you remember from last year, but if we look at what we found, and if you remember the rule, we will get onto this in the next section, but the rule is you multiply that 3 by that 2, you get 6x, and then you take 1 from the power, 6x squared. Multiply that 2 by the 3, you get a 6. Subtract 1 from the power, you get x to the power of 1. And that's exactly what we've got here. Okay, so you've learned how to find derivatives by first principle. And that's it for 9A.